Hi everyone, for this question it asks us to express this fraction as partial fraction, hence evaluate this integral. Given the answer correct to three significant figures. First of all, we identify this fraction whether it is proper or not. So up here is quadratic. Denominator here is x squared times x, so means this is cubic. Up here is quadratic, so this is proper. Power 2 is less than power 3. So we can proceed. For second step, make sure our denominator is factorized completely. For x squared plus 3, this one no longer can be factorized anymore, so it will be remain in quadratic factor. Then next, you will separate according to the factor. After that, we're going to determine our constant. When we have linear factor, up here will be constant as numerator. When we have quadratic, so up here will be linear, so bx plus c. Then we get same to the denominator where this unknown ABC will time with the factor it don't have. So when this a having the factor 2x minus 1, so it will multiply with x squared plus 3. Meanwhile, for bx plus c put in bracket, together it will need to time with the factor it don't have, which is 2x minus 1. Then we can start let. We can let x equals to the roots. Let's say our roots from this factor is 1 over 2. Then another roots we can find is x equals to 0. When we have linear bx plus c, we can eliminate b. Then lastly, we can let another value as random value, let's say x equals to 1. So when x equals to 1 over 2, we substitute. It gives us negative 39 over 4. So when we substitute 1 over 2 here, 1 over 4 plus 3. Then when we substitute this one 1 over 2, this factor make it 0, so everything will become 0. We will manage to find a first. So a, it will give us negative 3. Then we continue for another value. So we have 3 unknown. We must have letting here x value for 3 times. For x equals to 0, left hand side negative 9. A, we already know negative 3 times 3, 0 here. So 0. Here we have c times negative 1. So 0b plus c, 0 plus negative 1. So from here we can find c. C will be 0. Then lastly, we substitute x equals to 1. When x equals to 1, left hand side is negative 10. So right hand side we follow through. A is negative 3. Then 1 square is 1 plus 3, it will be 4. Then 1b plus c. Then 1 times 2, 2 minus 1 is 1. Lastly, we get to find b, which is 2. So we express our fraction in partial fraction form. Substitute back our a, b, c. A is negative 3. B is 2, C is 0, then after that we're going to evaluate this integral. So to evaluate this, integrate 1 until 2, this fraction is already expressed in partial form, so we substitute the partial form. So for the fraction having the denominator as linear, this one we can use formula number 6, where integrate 1 over ax plus b dx, it will give you straight away ln ax plus b, and divide by the coefficient x, which is a. So another form, special form in fraction, it will be fx, up here f prime x. To integrate this, we can get ln fx straight away plus c. So for the second term here, look like our denominator is not linear, so we try to see whether it is having the special form pattern. The function at denominator is a quadratic. When we differentiate this quadratic, we get 2x. So we having this pattern where denominator is our fx, numerator is a differential function. Therefore, we can integrate this directly using formula. So negative 3 take out, here will be ln 2x minus 1 over the coefficient of the x is 2. Meanwhile, this one is be ln fx, x squared plus 3. Then upper limit 2, lower limit 1. Then we substitute our upper limit minus lower limit to evaluate the answer correct to 3 significant figures. Substitute x equals to 2. Then substitute x equals to 1. Then we evaluate using calculator. So give our answer to the 3 significant. So 1.088, it will be 1.09. Round off to 3 significant figure as the question asks here. So that's all for these questions.